breaker panels and breakers, circuit breaker panel boards. These are probably the most common types that home inspectors will come across, as they have replaced fuse panels since around 1960. Circuit breakers are far from being perfect safety devices and require some testing and monitoring. Breaker panels go farther back than many people realize, having been patented in 1910. However, it is unusual to see a residential breaker panel from before 1940. Prior to this, electrical breakers were primarily used in manufacturing and naval applications. Breaker panels started appearing in homes in the mid-1950s in small numbers and were universal in most areas in the United States and Canada by the late 1960s. Circuit breakers did not replace fuses due to any deficiency of the older technology. The problem was that when a fuse blew, a person had to go find a replacement. Breakers are obviously more convenient because when they trip after a fault, they can be reset without replacement. We now have added benefits from circuit breakers with the advent of both ground fault circuit interrupters, or GFCIs, and arc fault circuit interrupters, AFCIs, in many locations. Circuit breakers. Circuit breakers are the most commonly used form of overcurrent protection in residential wiring. Code requires that an overcurrent production device, like a circuit breaker or fuse, be installed in series with each underground conductor or hot wire at the point where the conductor receives its supply inside the panel board, except for service entrance conductors. Conductors are rated to operate at maximum temperatures, and circuit breakers serve to open the circuit, disconnect or turn off, and protect the conductor if the temperature in the conductor rises to a level that would damage the conductor. Circuit breakers fall into 4 categories. 1. 240-volt double breakers. 2. 120-volt single breakers. 3. GFCI breakers. 4. AFCI breakers. All of these require some specialized knowledge to properly evaluate. Remember, we are talking about energized components. Safety is paramount when investigating electrical panels and overcurrent protection devices. Most circuit breakers are designed to accept only one wire. For those breakers, there can be only one wire under the screw or lug. The practice of attaching more than one conductor to a single circuit breaker, known as double tapping, is generally discouraged due to safety concerns. However, there are certain circuit breakers that are specifically designed to safely accept more than one conductor. These breakers are often referred to as dual lug or multi-wire breakers. One manufacturer known for producing such circuit breakers is Square D. Square D offers certain circuit breaker models, particularly within their QO line, that are UL listed for 1 or 2 conductors. These breakers are specifically designed with dual lug terminals, allowing for the secure attachment of 2 conductors. 240-volt circuit breakers. Our homes require high voltage and amperage circuits to run appliances such as dryers, air conditioning, stoves, and additional breaker panels. Appliances that are 240-volt are fed from 2 120-volt conductors, each connected to a separate bus bar in the electrical panel board. It is imperative that when one of the circuits trips due to an overcurrent condition, both conductors are de-energized at the same time. If not, someone could be trying to repair an appliance that is still partially live. For this reason, all breakers supplying 240 volts are required to have the handles tied together by a listed handle tie. Nails, screws, or scraps of wire, for example, are unacceptable. Sometimes the breaker is molded with this connection in place, and sometimes they are linked by a listed handle tie. The inspector should ensure that the tie is present and has not been damaged. A 240-volt circuit breaker also acts as the main disconnecting means in modern panels, disconnecting all the electrical power in the home. Handle ties. 240-volt breakers have 2 handles that must move together. There must be some device, like a clip or pin, that makes the 2 handles act as one or move together. Also, tandem breakers that are on a multi-wire branch circuit should have handle ties, although this has not always been required. 120-volt circuit breakers. Common 120-volt circuits are fed from one bus bar only. Also in use are tandem breakers, which are 120-volt breakers that feed 2 separate circuits, each controlled by its own handle. These should not be linked. As with fuses, the inspector should check that the rating of the breaker does not exceed the rating of the conductors unless allowed by code. Otherwise, something other than the breaker is likely to overheat and fail. There are 2 manufacturers of single-pole 120-volt breakers who have their products listed for 2 conductors. These are made by Square D and Cutler Hammer. These should not be confused with double-tapped breakers, where more than one conductor has been incorrectly connected to a single breaker. GFCI breakers. Ground fault circuit interrupter, GFCI breakers, are one of the ways to protect circuits and people from ground faults. Not all circuits are required to have GFCIs, and in many homes, the locations that require this protection have their own GFCI receptacles. However, if a GFCI breaker is installed at the panel board, it will provide protection to all receptacles downstream from that breaker in that branch circuit. AFCI and GFCI breakers have integral trip and reset buttons to help ensure that they are working properly. The home inspector should trip the breaker using the test button and ensure that the circuit has indeed been switched off. AFCI breakers. Arc fault circuit interrupters, or AFCI breakers, have been required in new construction since the 1999 edition of the NEC. Many jurisdictions are now observing recent code additions which have expanded the use of AFCI devices to almost everywhere within a dwelling. These breakers are designed to trip if they sense arc faults in the circuit, which are caused primarily by damaged wiring. What is an AFCI? Arc fault circuit interrupters, AFCIs, are special types of electrical receptacles or outlets and circuit breakers designed to detect and respond to potentially dangerous electrical arcs in home branch wiring. As designed, AFCIs function by monitoring the electrical waveform and promptly opening or interrupting the circuit they serve if they detect changes in the wave pattern that is characteristic of a dangerous arc. In addition to the detection of dangerous wave patterns, such as arcs that may cause fires, AFCIs are also designed to differentiate safe, normal arcs. An example of this arc is when a switch is turned on or a plug is pulled from a receptacle. Very small changes in wave patterns can be detected, recognized, and responded to by AFCIs. A brief history. In the 1999 NEC, these breakers were required only on bedroom receptacles. In the 2002 NEC, they expanded to all 15 amp and 20 amp single-phase 120-volt branch circuit supplying outlets. The 2005 NEC expanded their use to allow AFCI devices similar to GFCI receptacles, but none existed on the market, and their use was limited by 210.12b. Finally, in the 2008 NEC, the use of combination-type AFCIs expanded to 15 and 20 ampere branch circuit supplying outlets installed in a dwelling unit's family room, dining room, living room, parlor, library, den, bedroom, sunroom, recreation room, and similar rooms, including hallways and closets. Many people confuse the term combination to mean AFCI and GFCI together in a single device. This is partly correct only in that most AFCI devices offer Class B type of GFCI protection, which usually starts at around 20 to 30 milliamps, and do not offer any personal protection, as do conventional GFCIs. The combination type AFCIs are designed to activate when there is a parallel arc that reaches a peak of 75 amps. The combination refers to the fact that AFCIs now protect against series arcs as well. They have a 5 amps peak threshold. This is where the term combination comes from. Remember, the term outlet is not interchangeable with receptacle. Outlets are defined by the NEC as a point on the wiring system at which current is taken to supply utilization equipment. Recess lights, smoke alarms, receptacles within outlet boxes, and so on are supplied from outlets. It is likely that many more locations, and maybe even the whole house, will be required to have arc fault protection with future code revisions. As with GFCI breakers, these should also be tripped with their test buttons, and the current should be checked to make sure it has been shut down. Inspecting circuit breakers. The inspector should pay special attention to the following questions and report any deficiencies as in need of immediate repair. Does the breaker exceed the capacity of the conductor? Does the breaker have multiple incorrect taps? Do the 240-volt breakers have their handles tied properly? Do the GFCI breakers test and reset properly? Do the AFCI breakers test and reset properly? Is there any sign of overheating, arcing, or smoke damage on any of the breakers?